Hello guys, and welcome back. Today I just wanted to talk a little bit about conduit bending. Basically for beginners. So, if you're an experienced electrician or conduit bender, this video might not be for you. So these are just bare basics for beginners. No pun intended, let's begin. These are the basic sizes of EMT conduit that you're going to bend with, or possibly could bend with. A manual bender. Manual bender is this one right here. Of course, it has a longer handle, floor grip, and force conversion. So as you can see, conduit comes in two types, EMT and rigid conduit, and can be found in various sizes. To aid bending when performing a ground or air bend, benders are marked with different alignment symbols to help the operator create the bend necessary to accomplish the project. Symbols found on inclined tools. Benders are the arrow, the teardrop, the start point, the angle markings. These markings are found on various sizes of the bender head. So, keep in mind, these are all the markings they're talking about. Basically, your beginning point, your center point, your degree point, and your back bend point, 93 point, 22.5 degree, 30 degree, 45 degree, 60 degree, and finally, 90 degree. And this barber sheet shows you the stub up, which in this case is 6 inches. Most common methods to know how to make are the 90 degree stub up, back to back, offset, and the 3-point saddle bends. This commonly use a combination of the bended markings when marking certain tube profiles. Knowing the proper technique and method of making bends will allow you to accomplish most projects efficiently. Things to remember while bending. A proper bend is made by rolling the conduit about the bender in the conduit's cradle using output pressure. Use a correct size bender for the conduit size being bent. Some over bending may be required to allow you to spring back of the conduit. The resting condition of the conduit is to be at the final angle desired. Make sure and properly mark your conduit using the tables and information provided. For bending, make sure your conduit is secure so it does not slide prior to bending. Apply ample foot pressure to the bender's heel while minimizing the use of the handle as a lever but more of a guide. Air bending. Make sure handle's heel is secure on the ground and it is reinforced by your foot so it does not slide down. Make sure you are balanced and apply force close to the tool and your body controlling the tubing as you bend it around the bender's cradle, making sure the conduit does not slide and the bender head. To prevent injury, always wear protective gear and do not overexert. And when talking about protective gear, talking about PPE, goggles, gloves, steel-toe boots, and, in most cases, hard hat. "90-degree stub-up bend. The stub-up bend is made by bending a piece of conduit into an L-shaped or 90-degree angle bend by placing the free and short end of the tube to a predetermined length, as indicated in the diagram below. This is the most common bend and is a building block for other bends. Common uses for this bend are running conduits into electrical boxes, running conduit up or down walls, running conduit into walls through floors and ceilings, and making inner and outer corner cut. These are the sizes of the conduit and the stub-up height. So if you bend at the arrow point, the ½ inch will give you 5-inch stub-up height. A 3/4 inch EMT will give you 6-inch. A 1-inch EMT will give you an 8-inch. And an 1.25 EMT will give you an 11-inch. So first, determine the overall free end height of the conduit you want after the bend. From the overall free height, subtract stub height distant in the bender, take off cable for the conduit size you're bending. On the conduit, measure from free end to be bent up, calculate a number, and mark the conduit. Always use the proper size conduit bender for the conduit size being bent. The conduit will not bend properly and or will be damaged if a mismatched bender and conduit size is used. Place the bender onto the tubing with the hook pointing towards the free end to be bent upwards. Make sure the conduit is resting properly in the bender's hook. Then line up the arrow symbol with the mark you placed on the tubing. Like I said before, the arrow is the beginning of the bend, as you can see in this image right here. Keeping the conduit flat, apply ample foot pressure to the bender's heels, minimizing the use of the handle as a lever. Rolling up the free end into a 90-degree position, checking the degree with a level. When done properly, the free end will be at the side height, and the arrow will be at the stub height as indicated. Back-to-back bends. Back-to-back bends is the next style of bend that is needed while running electrical conduit. In reality, the concept is formulated by the need to know the distance from the back edge of a 90-degree bend to the fixed point down to the conduit mark. For other bend operations to meet the installation requirement. As you will see, it built on the 90-degree stub bend. And when done, the most common use of this bend will look like an elongated U. You will need to know the bend method when you want to fit conduit between two parallel surfaces, such as two walls or joists, while keeping the U's outer edges of the legs touching the two surfaces. This allows for proper anchoring and a nice, clean appearance. First, determine the distance between the two parallel surfaces to get the dimension for back-to-back bend. 2. The first bend for the back-to-back bend is 90-degree stub-up bend. Follow the steps from the 90-degree stub-up section to create the ideal bend for the connection on the first side. 3. From the back edge of the 90-degree stub-up bend, measure the distance found in step 1 and make your mark on the conduit. 4. Place the bender on the conduit with the bender's hook facing the free end of the tube to be bent opposite the original bent side. Make sure the conduit is resting properly in the bender's cradle and line up start point symbol mark placed on the conduit. As you can see right here, if sorry for the quality, guys, this is the best I could find on the internet, but if you can see right here, that's where the start is. Fine. Keeping the conduit flat, apply ample for pressure to the bender's heel with minimal use of the handle as a lever. Rolling up the free end into 90-degree position, checking the degree with a level. It is very important to keep the first 90-degree bend in the same plane as the new bend. If not, the two legs of the U will be skewed and will not produce the desired shape. If this happens, some correcting can be done to properly align the legs depending on how out of shape they are. When the bend is done properly, the conduit will lay flat and will fit on side the two surfaces measure. And right here you can see a perfect representation of a back-to-back bend. If the back-to-back distance is short, a tight U, so the bend has problems feeding to make the second bend, you may compensate by subtracting the stub-up height from the measure distance to fit the gap. Then follow up step 3 to mount the calculated number of conduit. But this time you will put the bender on the conduit with the hook facing the first bend in the line up arrow symbol as demonstrated in the stub-up section. Step 5, with the conduit marking, proceed to make the bend, as in step 5 rolling up the previously bent end up into a 90-degree position, giving you the desired dimension. Offset bends. An offset bend is a style of bend that is built independently of the 90-degree bend, stub, and back-to-back bend, and is an important bend to know when running conduit. It is common to shift the conduit a certain distance while continuing to run parallel in the same direction as the pre-shift portion of the conduit. There are many situations that call for an offset bend. The most common uses of this bend are staggered joists, running tight on a wall, and offset into an electrical box, and changes in elevation. These are the 3 bends, constant multipliers for the distance, which is right here, and the shrinkage, which will be this distance travel as height versus angle. You get this shrinkage right here. And it tells you right here, 1/2 inch, 3/4 of an inch. 1/4 of an inch, almost 1/4 of an inch, and 1/8 of an inch. First, determine or measure the offset distance necessary to clear the obstacle on the outline. The offset will need to be bent from the end of the conduit. 2. Decide at what angle you wish to make the offset bend and determine the proper values from the offset formula table. Calculate the proper values to mark on the conduit to clear the obstacle and fit in the gap measure. 3. From the table, use the 45 by 45 offset row for the values to calculate the series of markings necessary to make the proper bend. To find out when to place the first mark on the conduit, multiply the measure offset distance to clear the obstacle by the table's shrink inch. Then we'll return to the conduit after all the bends are made due to that offset distance. Or offset distance times shrink h in total shrink. For using the technique to align the bender on the conduit as described under the stub of section 5, place the bender on the conduit with the hook facing away from the second mark, and line up the arrow symbol up with the first mark. Five, keeping the conduit flat, apply ample foot pressure with the bender's heel, minimizing the use of the handle as a lever, smoothly rolling out the free end until the 45-degree mark is reached. When done properly, the free end will be at a 45-degree angle from the original plane. 6, keeping the bender and conduit together, flip the two parts upside down and put the bender's handle hilt on the floor. Balancing the conduit in the air, allow the conduit to rotate 180 degrees in the cradle. Slide the conduit down so the first bend is moving away from the bender's head. Aligning the second mark as I've outlined before using the arrow symbols. 7. Second bend of the offset is accomplished by performing an air bend. Make sure the handle hilt is secure on the ground and is reinforced by your foot so it does not slide out. Make sure you're balanced and apply force close to the tool and your body controlling the tubing as you bend it around the bender's cradle. Bend the free hand up until the 45-degree angle mark is reached. It is very important to keep the first 45-degree bend in the same plane as the new bend will be. Now, the two legs of the offset will be skewed. It will not produce the desired shape. If this happens, some correction can be done to properly align the legs depending on how out of shape they are. When the bend is done properly, the conduit will lay flat and fit inside the measured distance to and clear the obstacle. 3-point saddle bend. The 3-point saddle bend is a variant of the offset bend since it is an offset bend that returns to the original inline run after clearing the obstacle. This bend is intended to bridge over obstacles such as existing conduits or plumbing run on perpendicular to the intended conduit installation. So first, determine or measure the offset distance necessary to clear the obstacle and how far away the saddle band will need to be from the edge of the conduit. Unlike the offset band, you must measure to the center of the obstacle to reach over. 2. Choose the angle that will be used for the center bend. The other two return bands will be half the center angle chosen. If the center angle is 45 degrees, the two return bends will be 2.5. Use the table to calculate the distance between bends and how much shrinkage is to occur to the conduit due to the bends. Here's the table. Take your time to read and analyze it and think about the numbers. I know it's confusing at the beginning, but it will all make sense down the road. And be patient, because everything comes with practice. Practice, practice, practice. Number 3, calculate the value needed to place your first mark on the conduit. This number is determined by measured distance to center corn of the obstacle, plus the shrinkage from the 3 corn saddle band that will occur. So as you can see right here, it's telling you measure distance to center plus the shrinkage equals to center mark. Number 4, using the distance of center mark values on the table clear to each obstacle, simply mark that distance from the center line of directions or subtract this number from the center mark value for the first return band mark and add that number to the center mark value to obtain the second return band mark distance. Right here it says center mark minus distance off center mark equal first return band mark. Second band is center mark plus distance off center mark equals second return band. Fifth step is mark the conduit accordingly. Sixth step, place the bender on the conduit and position the proper center of the bend ring notch on the center mark in the accreditation shown. Seven, keeping the conduit flat, apply ample foot pressure to the bender's heel, minimizing the use of the handle as a lever. Slowly rolling up the free end until 4D flat ring mark is reached. Number 8, keeping the bender and conduit together, flip the two parts upside down and put the bender's handle heel to all four. Balancing the conduit in the air, allow the conduit to rotate 180 degrees in the cradle. Slide the conduit down so the first bend is moving away from the bender's head. Align in the first return bend mark with the arrow symbol. The second bend of the saddle The second bend of the saddle bend is accomplished by performing an air bend. Make sure the handle heel is secure on the ground and it is reinforced by your foot so it does not slide out. Make sure you are balanced and apply force close to the to the tool, and your body controlling the tubing as you bend it around the bender's cradle. Bend the free end until the 22.5 mark is reached. Number 10. Remove bender and place it back on the Conduit on the other side of the center bend, with the hook facing the center bend as before, aligning arrow symbol. Number 11. The last bend on the saddle bend made again by performing an air bend. Make sure the handle hilt is secure on the ground and it is reinforced by your foot so it does not slide out. Make sure you're balanced and apply force close to the tool and your body controlling the tooling as you bend it around the bender's cradle. Bend the free end until the 22.5 mark is reached. It is very important to keep all the bends in the same plane. If not, the offset will be skewed and will not produce the desired shape. If this happens, some correcting can be done to properly align the legs depending on how out of shape they are. When the bend is done properly, the conduit will lay flat and will fit the measured distance to obstacle. Clear the object and return to the original line conduit. Clear the object and return to the original line, continuing the run as desired. And that is it for today, folks. This is, or was, the beginner's guide for EMT conduit bending for beginners. As always, thank you guys so much for watching. If you like my videos, please like, share, subscribe, and comment. Thank you, and see you in the next one.